So here we are in the part C of our differential calculus problem. So we have here our given, which is f of x is equal to x cubed minus 3x plus 1. And first we need to get the first derivatives, which is 3x squared minus 3. And then the second derivatives is 6x. So to solve for our critical numbers, we need to use our first derivatives. Then let f of prime x is equal to 0. So 0 is equal to 3x squared minus 3, and then we need to factor it out. And therefore, we have our critical numbers, which is x is equal to -1 and x is equal to 1. Now, to get our relative maximum, we need to substitute our first critical number to our given function. So, when our x is -1, we need to substitute it -1 cubed minus 3 times -1 plus 1. So we have our answer, which is 3. And then for our relative minimum, when x is equal to +1, we have 1 cubed minus 3 times 1 plus 1. Then we have our answer, which is -1. So now we have 2 points of inflection, which are A, the x-intercept is -1 and our y-intercept is +3. And for B, our x is 1 and then y-intercept is -1. Now next, we need to get our regions and intervals. So we need to start first with -infinity all over to our first critical number, which is -1. And then from -1, we will proceed on our second critical number, which is +1. And then to know if these regions are increasing or decreasing, we need to test it. So we have here the interval of -infinity and -1, which is -2. And if we substitute it for our first derivatives, we will get -15, which is decreasing because of its negative value. Next, for -1 and 1, we will use 0 because it is in between -1 and 1. So if we substitute it on our first derivatives, we will get -3, which is again decreasing. Now, to get our concavity, we will substitute our test numbers into second derivatives. So first, we have -12, and basically it is concave downward because it is negative. And second one, we have 0, which is concave upward. Then I will show the graph